welcome then to these shape revision notes. So let's get straight to it. These are all calculator allowed topics. So for this revision, you need to use your calculators. All right. So let's get to it then. First question, 2D trigonometry. Okay, so let's just put that head in. All right, and then come back when you're ready to have a go at these questions. Okay, welcome back. Remember, standard trigonometry in right angle triangles is all about sine, cos, and tan. I always use the mnemonic SOHCAHTOA to remind me about what's going on. So question A then, shall I call this one question A? And this one B? And this one C? If I'm doing question A, remember the first thing with trigonometry is to label the sides. Remember the long diagonal side is called the hypotenuse, H. This side opposite the angle is called the opposite. All right, so I'll get rid of that A. It's going to be a bit confusing otherwise. And this side here, remember, the side that's next to the angle is called the adjacent, lowercase a. So if I'm doing these, I always write down SOHCAHTOA and see which one we have to use, sine, cos, or tan. Okay, well, I know A, but I want to find O. So I'm going to use tan. Okay, so I know that tan 34. And I know tan is O over A. All right, so it's going to be O over 7. But I don't know what O is. I know that A is 7. I remember now, you could work out tan 34 on the calculator, but the quickest way to solve this is to just multiply it by 7 to get rid of the 7. So you're going to get 7 times tan 34. I'll put it in brackets because it's good style. If you do 7 times tan 34, you get 4.72 centimeters, 2 decimal places. Okay then. Part B, again, label the sides. H, O, A. All right, so write down SOHCAHTOA again. So I know O, but I want to find H. So I'm going to use sine. Remember now, sine 51 degrees. Remember, sine is O over H. All right, so it's going to be 12 over, you can call it H or B, it's up to you. All right, I'll call it H because I labeled it H. Remember now, if I do a little separator here, sorry. Remember now, in this first example, the unknown was on top, so I multiplied. But if the unknown's on the bottom, you divide. So this one now, okay, I'm going to get H is 12 divided by sine 51. But we say if it's on top times, that means if it's on the bottom, you divide the unknown. So sine 51, close bracket, and I get 15.44. This time it's meters to 2 dp. Part C then, again, label the sides, use the angle. So that's O, that's H, and that is A. So this one now, again, write down SOHCAHTOA. Again, what do well, I know H, and I know A. So I'm going to use cos. And this time I don't know the angle. But I know the cos of the angle, remember this letter here is called theta. Cos theta, remember, cos is A over H. So it's going to be 3.5 divided by 10.5. All right. Remember now, if you want to get rid of this cos, but you take the inverse function. To find an angle, you take the inverse function. So don't forget that. So on the calculator, if you do shift then cos and bring up the inverse cos, 3.5 over 10.5, you are going to get 70.53. Remember, it's an angle, so degrees to 2 dp. And with that, we're done. So next question. Okay, question 2 then is 3D Pythagoras and trigonometry. just check it. Yeah, there's only one question on this, but it's quite lengthy. So pause the video, come back when you're ready. Okay, so for this question, my top tip here, okay, is to try and turn a 3D problem into a 2D problem. So look for 2D triangles you can use. Okay, because we can do 2D trigonometry easily and do 2D Pythagoras. 3D a bit more difficult, right? So this is a square base pyramid. So that means all the sides on the base of 30, and it's got height 18. I can see that. The base ABCD has got length of 30, and E is the top of the pyramid. It's above O, the midpoint of the base. Yeah, I understand. So find the length of AC. Okay, well, first things first, isn't it? Where is AC? Get my highlight right. Here's AC here. This long line here. And I already see that if I'm looking for right angle triangles, I know it doesn't look like a right angle because of the perspective, but this here is a right angle in it, okay? Because it's a square base pyramid. So I can see a triangle. I go over it all now in yellow. Hopefully it'll work if I go over it in yellow. Yep, here we go, look. I'll use this triangle here. And I will redraw it. Okay, and I'll draw it straight up. I'll pull out the page and put it face up, okay? Like this. So that would be A, that would be C, and that would be D. Okay, I know this here is 30 centimeters, and I know this is 30 centimeters. I'm trying to find this side here. So I will call it X. Now this one, you wouldn't use trigonometry, you would use Pythagoras because you've already got two sides in a right angle triangle. Remember Pythagoras is A, B, and C. C is always the hypotenuse, and A and B can be the other two sides in any order you want. So if you do remember, A is the famous theorem, A squared add B squared equals C squared. Remember, A squared is going to be 30 squared, which is 900. B squared is also 30 squared, which is 900. And if you add these together, then you get 1800. And below to find C, you will do the square root of 1800. So the root of 1800 gives me 42.43 centimeters to 2dp. So, and I found that, put it on the picture. So this whole length is 42.43, the whole length, okay, centimeters. And I've done question A. No props. Right, therefore work out the length AO. Oh, okay, well, AO is here. Surely that's just half of 42.43 because O is the midpoint of this line. Yeah, so AO is half of 42.43. So I just divide by 2. So 42.43 divided by 2 gives me the two decimal places, 21.22 centimeters to 2dp. Okay, so just this small part, this halfway mark is 21.22 centimeters, all right? And now, this is B part 1, sorry. Now B part 2 is the angle OAE. Right, so I better think about a triangle I can use now. Again, maybe I'll go with this one in green. So angle OAE. All right, so angle from O to A to E. Right, okay, no worries. Well, this again is a right angle triangle because this is a straight line up here. This is actually a right angle triangle here. So I'll redraw that triangle again, flat, so you can see what's going on. We've got a right angle there. That's O. That's E. And this is A. I'm trying to find an angle OAE. That's the angle at A. So I will call it theta, okay, because that's the general letter we use for an unknown angle. What do I know? Well, I know this is 18. See, you see it? And this length from A to O is 21.22, and we just did it. All right, and these are both in centimeters, sorry. So I can use standard trigonometry. H, O, A. Let's write down SOHCAHTOA. Oh, I'm pretty sure you can guess which one it's going to be by now. So what do I know then? I know O and I know A. So I'm going to use tan. Okay. So tan theta is O over A. So 18 over 21.22. Remember here, this time round, you're going to take the inverse tan function. So the inverse tan of the fraction, all right, 21.22, and see what you get. So shift tan 18 over 21.22 gives me 40.31 degrees, because it's an angle to 2dp. Okay, and that's that question done as well. Nice one. Question 3 then, on circle theorems. The hardest part here is memorizing all the circle theorems, because there's seven altogether higher tier. Okay, so first one, O denotes the center of the circle. Yeah, no probs. Find angle X given a reason for your answer. Well, this is a very easy one, isn't it? Okay, because it's probably the first theorem you were shown. Remember, if ever you see an angle at the center and then an angle at the edge from the same points, remember the formula? The angle at the center is double the angle at the edge. Okay, so the angle at the center is double the angle at the edge. So X is going to be 53 degrees times 2, which is 106 degrees. And the reason is the angle at the center is double the angle at the edge. Very important first theorem right there. Okay, job done. 3b then. So AC is a diameter of the circle. I can see that it goes from edge to edge from the center. So that's the center there, I call it O. BC is a tangent. Yep, it's a line that just kisses the circle and moves on. AB is a straight line which intersects the circle D. I see that. DCA is 64. See it. Work out angle X. Okay, no worries. Well, give a reason for each step you're working. Well, okay, so if I break it down in steps, this is step 1. You just do what you can do, basically. All right, you just do what you can do. First thing I'm going to spot is I see a semicircle here. Okay, and what you would have learned in one of the lessons on circle theorems is that the angle at the edge in a semicircle is always 90 degrees. Okay, now this angle here is a right angle, and that's called angle ADC. So you can say that ADC is 90 degrees, and the reason is, okay, it's an angle in a semicircle. And again, I think that means now that this one here also, I'll call that angle BDC. That also equals 90 degrees because it's on a straight line with the other 90 degrees, and they have to add up to 180 degrees in a half turn on a straight line. So if I can find this one here now, then I'm going to win because I'll have angles in a triangle I can use. So can I work out angle DCB? Yes, because of another theorem. Remember the theorem that says if you have a tangent and the radius, remember, they always meet at 90 degrees. So this entire angle here is a right angle. So I believe then that is pretty obvious that the missing part, I've already got 64, the missing part will be 90 take away 64, all right, which is 26 degrees. And that you can just say for this one, all right, tangent and a radius make a right angle. Now, if you put that on the picture, the fact that this angle here is 26 degrees, once my pen wakes up and my ball stops skipping, sorry, then step 4, angle X is going to be 180, take away 90, take away 26, okay, which I think is 64, because angles in a triangle sum to 180 degrees. Okay, that's that one done. Quite a complicated one, but if you remember all the theorems, then you can't really go wrong. Okay, and then question C. In this diagram, the tangent STU meets the circle T. I see that. Find angle Y, giving reasons for your answer. Okay, well, again, I'm looking at this now. I'm struggling a tiny bit here to find Y straight away. But you can use a couple of steps here, can't you? All right. The way I see this one, this is going to be, I'm going to be using the alternate segment theorem here. Remember, when a tangent meets a chord, all right, then the angle is the same in the alternate segment. So I know, see, this angle here, Y, is going to be the same as that one there, for example. All right, that's one way you can do this one. But similarly, that could work backwards as well. If I erase the green highlighter, all right, then, and do it again with the highlighter, then similarly, look, see, there's the tangent again. This chord would then make sure that this angle here will be equal to this angle here by the alternate segment theorem. Okay, so I can say this is called angle R. I'm going to call it angle RTU. RTU is 56 degrees by the alternate segment theorem. So put that on the picture. And actually now, and I can work out this Y here very easily, because this angle Y surely will be 180. Take away 42, take away 56. Why is that? Because I have got the classic half turn straight line shape there, okay? And angles in a half turn have to add up to 180 degrees. So Y actually is 82 degrees because it's on a straight line. All right, that's one way to do that question by using the alternate segment theorem. Is there one more question on this topic? There is. One more then. So find the values of X and Y. When I look at this, I always spot a really cool shape here, okay? I see a quadrilateral, okay, with all four corners, see, on the edge of the circle. But this is called a cyclic quadrilateral. And these things, quadrilateral, these things have got an amazing property. Remember on these shapes, the opposite angles add up to 180 degrees. So these two add up to 180 degrees, and the 5y and the 4y add up to 180 degrees as well. Remember, the theorem is opposite angles in a cyclic quadrilateral sum to 180 degrees. So what I can legitimately write down, I hope you agree now, look, 3x add x, okay, makes 180 degrees, because opposite angles add to 180 degrees. That means that 4x equals 180. And if you divide by 4, then you get that x equals 45 degrees. So x is done. Same for y then. Look, I can legitimately write down 4y add 5y is 180 degrees because they're opposite angles. That means that 9y is 180, which means if I divide by 9, I will get that y is 20 degrees. Very easy. And that's that question done. All right, nice. All right, so this one now is the sine rule, cosine rule, and area of any triangle. This would be quite a long topic here because it's quite complicated stuff. So this diagram shows the triangle A to B to C. Gotcha. Where's the question? Where's the maths? Find the length BC. Right, so BC is this one here. So remember, if you're using the sine rule or cosine rule, remember the triangle can't be right angled. Well, it can be, but use them if the triangle's not right angled. This one's not right angled, so we can't use standard trigonometry. So we know it's going to be the sine rule or the cos rule. Remember the labeling. Remember, if this here is, say, well, I want to find the length BC. All right. So remember, if this is angle A, then side A will be opposite angle A. This is side B with lowercase because it's opposite angle B. This is side lowercase c. So if I want to find BC, then that is actually side A. All right. So what can I do here? Well, normally I try and use the sine rule, but remember, to use the sine rule, you need at least one matching pair of sides and angles, and I don't have it here. Okay, I got B, but I haven't got angle B. I've got C, I haven't got angle C. I've got angle A, I haven't got side A. That means you have to use the cos rule. Okay, remember the cos rule says that A squared equals B squared add C squared minus 2BC times cos A. Okay, remember, you use the cos rule if you've got any two sides, like C and B, and the angle trapped between them. It's called an included angle. I call it an angle sandwich. Yum, yum. All right. Now I'm going to put my numbers into the formula. I get A squared is 4.6 squared plus 3.4 squared. Take away 2 times 4.6 times 3.4 times cos A. Remember, cos A, sorry. I know A, it is 87 degrees. So I'll put that in brackets, okay? Cos 87 degrees. And it's easy now. On the calculator, you can just work out this entire lump here. So put all that in the calculator, all right? And leave it on the screen. So if I do 4.6 squared plus 3.4 squared, take away 2 times 4.6 times 3.4 times cos 87, I get that A squared is 31.08, etc. I'll leave it on the screen, and then with a good calculator, remember, you can just do the root, can't you, of the above. So I'm gonna push root down my answer button, and I will get, if I do root of my answer, I get 5.58 centimeters to 2 decimal places. And I'm going to put that on the picture, okay, so I can make this triangle look a bit more inviting. Done. Right then, now I need the area of triangle ABC. Remember, the area of any non-right angle triangle, the formula is 1/2 AB sine C. Okay, but I can't use that version for this triangle because I don't know angle C. All right. Remember, you can interchange these letters basically. All right. Because I know angle A, I want this to look like this, sine A. And remember, the pattern is whatever angle you've got here, the other two sides go here. See, I had C here, then A and B here. So this one, if I got A here, I need B and C here instead. So I just have to do now 1/2 times B times C times sine 87 degrees. Okay, so 1/2 times 4.6 times 3.4 times sine 87 gives me, well, not a lot actually, 7.81. 2dp, remember, it's an area, so it's going to be in cm squares. Job done. Next question then. Oof, this is a big boy here. So ABCD is a quadrilateral. No probs. I see that. It's got 4 sides. AB is 5.8. BC is 13.5. Yep, tell me something I don't know. BAD is 115. Gotcha. DBC is 52. BDA is 35. I got it's all on the picture, but you got to check. Okay, but this might take me 2 slides this one now because there's a lot of questions to do. So first things first, work out the length BD. Right. So if we work out the length BD, so I'm going to have to try and work on a single triangle here, okay? I think I'll try and work on this triangle here, the green triangle, okay? I will redraw it. In fact, should I try redrawing it with a highlighter to make it ultra clear? This might go wrong, just to warn you. This may go wrong. Okay, I'll try redrawing this triangle. If it goes wrong, don't laugh. I'm just trying to make it as clear as possible, okay? Yeah, that's going to go pretty wrong. Yes, I'm not doing that. I will just draw it in red. Or maybe can I draw it? Can I draw it in a green pen? Can I draw it in a green? I could draw it in a green pen. There you go. Look. So it's got a slanted side here, a bit like this. Then you go. I know it's not an exact copy. Sorry. Okay. This is B. This is D, and that's A. And that's 115 degrees there. This is 5.8 centimeters, and this is, what else have I got? This is 35 degrees. No probs. Right. So the length BD. So BD, that if I label this triangle again, look, all right, this will be lowercase b, that'll be lowercase a, that'll be lowercase d there, all right? So BD, all right, is actually side A, all right? Luckily here, okay, I think I can use the sine rule because I could write down A over sine A, and I've got a matching pair, look. I could use D over sine D. See, I know side D and angle D. That's great news. So I can say that A over sine 115 is 5.8 over sine 35 degrees. And remember, to get rid of the sine 115 from the bottom, just multiply by it, okay? So you can just do A is 5.8 over sine 35 multiplied by sine of 115 and see what we get. So 5.8 over sine 35 times sine 115 close bracket gives me that A is 9.16 centimeters again to 2dp. So put that on the picture, okay? That was BD, that's 9.16 centimeters. Okay, part 2, hopefully this will fit on the bottom of part 2. Hence, find the length DC. Well, I'm probably gonna have to look at another triangle now, aren't I? Another triangle, which I'll do in, should I do it in blue? Yeah, because DC is in this triangle here, I will look at this triangle here. Right, the length DC. So if I redraw this triangle in blue, hopefully it'll work. I say I may have to go on to the next slide for this. I have to see how it goes, okay? Hopefully my pen doesn't disappear. It did. Sorry. Here we go. Like this, I suppose. All right. So like this, and like this. So this is B, this is C, and this is D. This is 13.5. All right. And this is 9.16. And this is 52 degrees here. So label my sides B, C, and D. The length DC now, right? I'll have to go over the other page now, all right? I'll write down first of all, DC is actually side B, all right? And I see this one, I can't use the sine rule because I haven't got any matching pairs of sides and angles. So I'm gonna have to use the cos rule. Okay, so I'll go on to the next slide now and I will use the cos rule. So bear with me 2 seconds. All right, so for this one, remember, I want to find B. So I'm going to have to do B squared first of all. All right, and remember that by the cos rule, right, you're going to have cos B over here. Remember then, see, there'll be the other two sides involved in the rest of the formula. So it's going to be C squared add D squared minus 2CD cos B. Okay, that's the way the cosine rule works. So put your numbers in. So what have I got then? I've got 9.16 squared plus 13.5 squared. 2 times 9.16 times 13.5 times cos of 52. Again, put the whole lump on the right hand side into the calculator. So 9.16 squared plus 13.5 squared. Take away 2 times 9.16 times 13.5 times cos 52 gives me 113.89, etc. That's b squared, sorry. I will then take the square root, so I will do root of the answer. So root of the answer gives me 10.67. Again, it's a length, so it's going to be in centimeters, right? The 2 decimal places, and put that on the picture. All right, this was 10.67 here. So I've done these two. Okay, so now we are on question 3 now, question part 3. What does question part 3 say? It says, use the sine rule to calculate CDB. Okay, well, luckily for me, look, CDB, angle CDB, belongs actually in this triangle here from question 2. Angle CDB is this one here. All right? It's actually angle D. So CDB is angle D. All right? So, and it says, use the sine rule. I like the sine rule, happy days. So this the version I will use here. Remember, if you want to find an angle, you can use the upside down sine rule with the angles on top. So I'm going to use, I want to find angle D, so I'm going to have to use the version sine D over D, and then with my other matching pair. Well, remember, this was 10.67 from the previous question, so these two match. I can use sine B over B. Sine B over B, all right? Then put your values in. Obviously, I don't know sine D. Side D is 13.5. And then sine B is sine 52. I think I worked out B, did I, just a minute ago? Yes, B is 10.67. Remember, the first thing here is to get rid of the fraction always. So multiply by 13.5. So sine D is going to be sine 52 over 10.67 times 13.5. If you are going to work that out, all right, then that's fine. You will get sine D is, let me do it in a fraction, sine 52, close bracket, over 10.67 times 13.5, and you get sine D is 0.997, etc. So remember then, if I do a little separator, say, let me cut this off by here, say, if I do a little separator, say here, if I come up here now, remember, to find the angle, take the inverse sine. So I will just do D is the inverse sine of my answer to get the best possible answer. So the inverse sine of my answer, I get that D is 85.57 degrees to 2dp. I'll put that in the picture as well. All right, this one here is 85.57 degrees. Okay, next one now, and then I got the last one on this mammoth question. I got to find the area of triangle BCD. All right, so this was 85.57. Now BCD again is here. All right, so I'm looking at this triangle. I should have everything I need now. All right, in fact, I have. Look, all right, I can just use this version. You could use sine B or sine B. I will use sine B because I know this angle's correct. It was given to me in the question. All right, my other one's correct as well, but in the exam you can't be sure. Never assume. So I'm going to use sine B. Okay, so if I'm going to use sine B, my area is going to be 1/2 times something times sine B. Remember, if you've got a B here, you've got the other two sides, which are called D and C here. So I'll use 1/2 CD sine B. So I just do 1/2 times, C is 9.16, D is 13.5, and sine B is sine 52 degrees. Put it in the calculator. So 1/2 times 9.16 times 13.5 times sine 52 gives me an area of 48.72 2dp, and again, they'll be in cm squares because it's an area, and my units for the question were in centimeters as well. Nice one. Okay, so the last question then, quite a long one again though. Graphs of the trig functions. Learn these off by heart, okay? So question A, sketch the graph of y equals sine x for values of x from minus 90 to 360. Right, well, you have to learn this off by heart, okay? Remember, the sine function's got a beautiful graph, okay? My y-axis and my x-axis. Now it says go from minus 90 to 360, okay? Remember, the sine graph never gets higher than 1 or gets lower than negative 1. So I go 90, 180, 270, 360. 180, 90 even. My bad, sorry. So I got 90, 180, 270, 360. It also said go back to minus 90 as well. You see? Remember now the sine graph? Sine naught is naught. So it starts at naught, goes up to 90, down to 180, down to 270, and naught to 360. Okay, and I'll do the minus 90 bit now. It's hard for me to draw this. I'll give it my best shot. Remember, it's a beautiful smooth wave. All right, remember, it's also negative 1 at negative 90, like this. This is y is equal to sine x. And that one's done. Okay. Now, part B, I'm asked for the cos function, this time from 0 to 360. So the cos function is basically the sine function's brother. All right, they're very close. We've got y and x again, 0. Cos never gets higher than 1 or lower than negative 1. I've got 90, 180, 270, 360. So 90, 180, 270, and 360. Remember now that cos is almost like sine, but it starts at 1. All right, one hand, then down here, and down here, and down here. Okay, so again, lovely smooth wave shape like this, and this is y equals cosine x. Okay, so use your graphs now to find all solutions for this range for this equation here. So I'm going to try and squeeze it by here so I can keep the graphs on the same page. Remember, to find the first solution, remember, just take the inverse sine of the right hand side, 0.84, 0.84804. So take the inverse sine, like we always do, 0.84804, and you get to one decimal, actually even 2 decimal places, you get 58 degrees, bang on to 2dp, because it's 57.99124, etc. All right, this is the first solution here. Remember now, there's more than one solution. If you look at the graph, and perhaps I'll do it in green, then remember 0.8484. This thing here, basically, you're looking at me for the same height, because 58 degrees. Well, let's say it's about here. Well, we know, don't we, that here I hit 0.84804. Okay, where does the graph get to the same height? Well, if you keep on going along, you can see it hits the graph again there one more time. So these two are the answers I need. I know this one here is 58 degrees. We've done it already. Remember now, these graphs are symmetrical. So take your highlighter. I will do my highlighter in yellow. See, by symmetry, this gap here and this gap here are the same size. All right, so this gap is obviously 58 degrees big. So this gap is also 58 degrees big. And because this gap is 58 degrees big, it's to the left of 180 degrees. So if you do 180, if you take off 58 degrees, because the gap is 58 degrees big, you will get the second solution. So 180, take away 58, gives me 122 degrees. And that's the second solution. See, there's no more solutions, because if you kept on reading across in the range from 0 to 360, you see it's not going to hit the graph again until somewhere about here, but that's out of my range. So I'm all done there. Okay, And the last one then, okay, might be a bit of a squash. Perhaps I'll put part D over here the way up, all right? So part D, I got cosine x equals negative 0.5. Again, to find the first solution, take the inverse cos, all right? So the inverse cos of negative 0.5 is actually a nice value. It is 120 degrees. But there's more. Look at your cos graph. 120 degrees, okay, is obviously going to be about here, right? About here, because it hits the graph at minus 0.5. So that there, okay, that there is 120 degrees. If you read across, look again, it hits it there. So if you read up now, I want to know what that value is there. Well, again, okay, you can do this two ways. If I do it, I go for the easiest way possible. I hope we can see that this gap here and this gap here are the same size, because they both go from the peak of this mountain, all right, it's actually called a peak, from the peak of the peak, pardon me, all right, to the actual angle. Because it's symmetrical, they're the same size. Now I know that this gap here was 120 degrees. This gap here is also 120 degrees. So I will just do 360 again. This, to see 360, take off 120. All right, and that will tell me what that is there. So 360 equals 120 gives me an answer of 240. Are there any more solutions? No, because if you keep on going, it's not going to hit the graph again until way over here somewhere, and that's definitely past 360 degrees. So that's that question done, and that's the note sheets done actually now. So if you cope with all this, you're doing great, because a lot of this work is A star here. So well done to you. Stay safe, and we'll see you soon.